All right, everybody. So we're going to take a look at the derivative of the natural exponential function. So the natural exponential function is just e to the x. So in this case, we're going to just take a look at how to find the derivative of e to the x. And it's probably one of my favorites because simply the derivative of e to the x with respect to x is just e to the x. That's it. It's the same thing. So it can get a little bit trickier if we start talking chain rule. So if you notice here, they have this u. What u would represent, u could be like x squared or x cubed. It's just something other than just x. And when we're dealing with the derivative of e to the u, it's going to still be the same thing, e to the u, but then we got to multiply it by the derivative of whatever that exponent is with respect to x. So let's take a look at a couple examples real quick. Derivative today. So we want to find the derivative of f of x is equal to e to the 2x power. So we take our derivative, f prime of x. Remember, we leave the e to the exponent exactly the same, and then we multiply it by the derivative of that exponent. So the derivative of 2x is just 2. So it's the chain rule. It's d outer, d inner. So we have f prime of x, if we want to write this a little bit nicer, would be 2 times e to the 2x power. Taking a look at another example here, if we want to find the derivative of f of x is equal to e to the negative 3x squared, right, we got a little more going on here. So it's the same rule though. We take the derivative, f prime of x, it's the exact same e power, e to the negative 3x squared. We multiply that by the derivative of the exponent. So the derivative of negative 3x squared is going to be negative 6x. And again, we could just rewrite this a little bit nicer. We have f prime of x is equal to negative 6x times e to the negative 3x squared. Now, it's right both ways, but if you prefer to write it this way. Try a couple practice and see how it goes.